So, welcome to this module, and in this module we will be performing the experiments that we have seen in the last module, which is the theory part about the band pass filter, right. So, we have seen how the band pass filter can be designed and how we can design the passive band pass filter and how we can design the active band pass filter, right. So, the idea is to cascade or to integrate the high pass filter with the low pass filter. Now, let us perform the experiments and let us see in reality what happens, right. So, for doing that concentrate on the screen and you see that there is a figure 15, right, where it is a high pass filter and low pass filter. Values are already given, values are given C1 R1 R2 C2, right. Now, once you connect the circuit as written here, so aim is to study the working of passive band pass filter. There is no active component, it is passive band pass filter. Connect the circuit as shown in figure 15, which is here. We will connect it here. R1 R2 values are given, 1 is done. Second, apply a 5 volts peak to peak sine wave at 50 hertz directly at V in. We will apply here this voltage is your 5 volts, right, and frequency is 50 hertz, frequency is 50 hertz. Observe the output V out. Here we have to observe what is the value of V out for varying frequency at a steps of 20 hertz, and note down its peak to peak output voltage, peaks to peak output voltage. Comment on the shape of the output and the amplitude at 159, the cutoff frequency, right, and at 1.5 kilohertz cutoff frequency of low pass filter. So, here we have designed the low pass filter with a cutoff frequency of 1.5 kilohertz, and here we have designed at 159 hertz the cutoff frequency. Okay. So, we have designed this because we have, how we can get this value, how we got this value, it is again very simple. I have told you earlier, f equals to 1 upon 2 pi R C, right. Put the formula, put the values in the formula, you will get this value. We put this formula, you will get this value. Now, you have the cutoff frequency for low pass, you have cutoff frequency for high pass, and let us see what we see at the output in this particular case, which is the passive band pass filter. So, I like to call Sitaram to help us show the circuit on the breadboard, and then we will see how the circuit looks like. It is a passive high pass filter and low pass filter. So, you can see the passive high pass filter and low pass filter, these are connected together. If you see my pen here, right, and this one, these are passive low pass and high pass filter, they are connected or integrated together. Now, we are applying the signal through the frequency generator. So, you can see what is the signal at frequency generator, we will see what is signal at frequency generator, and we will see that on applying the signal at frequency generator, what is the output in the oscilloscope, what is the output at the oscilloscope. So, let us focus on frequency generator, let us see. So, what we see, the frequency on the frequency generator we have set around 49 hertz, and the amplitude is 5 volts peak to peak, amplitude is 5 volts peak to peak, right. Now, on applying this signal, in the input of the high pass filter, at the input of the high pass filter, right, it will pass through the input which is high pass filter and the output which is low pass filter. However, high pass and low pass are integrated together or they are connected together. So, let us see the output signal at the output of the low pass filter, right. So, actually you do not get confused, this is nothing but high pass and low pass connected together. So, it is just band pass filter. So, input of band pass filter is the input to high pass filter and output of band pass filter is the output to the low pass filter. So, when you see, what you can observe is at the applying 5.12 volts, right, you can see that you cannot it is not allowing the same signal to pass through. It is not allowing same signal to pass through, that means that it is blocking this particular frequency, and you will also observe a very important effect that we have seen earlier called loading effect. Alright, we will observe the loading effect at a certain point. I will tell you when. So, now we are increasing the frequency, as you can see on the right bottom side, right bottom of your screen, that is if you talk about quadrants, right, the fourth quadrant, yes, that one for Q1, Q2, Q3, third quadrant, or you can say if it is Q1 then Q1, Q2. You can see frequency 59.14 hertz and frequency 58.99 hertz. So, yellow one is your input signal, blue one is the output signal. You can say frequency is okay, but the amplitude is not, that means that it is not allowing the frequency to pass through this particular filter, pass through this particular filter. Now, let us increase the frequency. Increasing the frequency, you can also see that peak to peak voltage is also increasing. We will increase it, the value for this particular high pass filter, the frequency that we have set is 159 hertz, right. So, we will see that when you come to 159 hertz or close to 159 hertz, you will see sudden jump in your output, right. So, still you are not able to see. So, you see the one thing is this is a maximum like 159.2 hertz, now it is allowing to pass, but still we cannot see the voltage at the output, right, which is 2.4 volts, and that is because of the loading effect, that is because of the loading effect. So, this loading effect we can remove if we use the operational amplifier, that is the active filter. That is why in most of the cases you will see that people do not use passive filter, because there is a loading effect. You can clearly see a loading effect coming into play. If we keep on increasing the frequency, we can pass the frequency until 1.5 kilohertz, and above 1.5 kilohertz again you will be able to see that the voltage is decreasing significantly. So, if you go and keep on increasing the frequency, you see it is 1.68 kilohertz, right. So, it is above your 1.5 kilohertz which you have set for the low pass filter, and that is why you are able to see that now again it will start blocking the higher frequency. So, it will only pass certain band of frequency, again you cannot see that significant difference, or we cannot understand that significant difference in the output, that is because of the loading. We cannot understand a significant or we cannot delineate actually when the loading is there, when the loading is not there, which band is passing, which band is not passing, that we cannot see because of the effect of loading. And that is why always remember, when we are going to use a passive filter, the loading will come into picture. So, no more passive filter, the passive filter we will not use, right. So, now if you come back to the screen, what we see that because of the loading effect that comes through the passive filters, if you can come back to the screen, okay, you will be able to see that the loading effect comes into picture, right, that we have seen already, and that is why we do not use the passive filters. We cannot use the, or we should not use the passive filters, right. So, what is the comment on the shape of output signal? Output signal follows the input signal with a voltage which is smaller than the input signal, and it is difficult to delineate between which band of frequency is allowed to pass, which band of frequency is not allowed to pass because of the effect of loading. All right. So, this is our comment, when we are using the band pass filter in the experiment. So, our experiment is on band pass filter, right. Now, instead of passive band pass, if I use a active band pass filter, then what will happen? That is a question, right. So, if you see the circuit here, again we have high pass, we have low pass, we have the amplification with the help of R2 and R1, right, with the help of R2 and R1. That means that this is which kind of amplifier? Quickly see, let us see what is the kind of amplifier. This is an inverting amplifier, it is an inverting amplifier. That means the amplification is R2 by R1, right, amplification will be R2 by R1. Okay, good, good. So what? So what we will be able to see is loading effect would not occur, alright. We will see this, we will see this. So if I want to design this, what should I do? I have to first connect the circuit as shown in figure 16, So I will connect my circuit in this particular format. I will apply the signal at the input using the frequency generator, or function generator, right. I will apply signal at the input using frequency generator or function generator. Then what is the next case? The next step is that the cutoff frequencies of this filter are calculated as 159.15 hertz, 1.59 kilohertz. This we have already seen in the example earlier in the last module, that if we use this particular circuit, our cutoff frequency or lower cutoff frequency FL would be 159.15 hertz, and our upper cutoff frequency or higher cutoff frequency FH will be 1.59 kilohertz, that we have already calculated, right. So now once we know the cutoff frequency FL and FH, what we will do? We will apply a 5 volt sine wave from 50 hertz at V1, this is V1, we will apply 5 volts sine wave 50 hertz and slowly increase the frequency at a steps of 20 hertz. Right. We will start increasing the frequency with a step of 20 hertz. It is same like passive filter. We are going to do the similar experiment. Only difference is now we have op amp. To help us. Alright. So let us see. Observe the output at VO. We have to observe the output at VO. Output voltage here at VO. And note down its peak to peak output voltage, and what we will able to see? We will able to see that a frequency that is equals to cutoff frequency, the amplitude is about A by square root of 2, while below and above the cutoff frequency, below the FL and above FH, below FL above FH, and above FH, we will be able to see that the cutoff frequencies and the amplitude is suppressed. Okay. So the point is that when we are going to use the active band pass filter, the points that we have to remember is: 1, once this we should have cutoff frequency which is lower cutoff frequency, which is higher cutoff frequency. 2, that we will, when on applying 5 volts peak to peak, if you will see that the peak to peak output voltage or the frequency which is cutoff frequency, the amplitude is of A by root 2, at cutoff frequency amplitude will be A by root 2, and below and above the cutoff frequencies, the amplitude is suppressed. Some amplitude is suppressed means what? Let us see what is meant by suppression of the amplitude. Let us see what is suppression of the amplitude. So if I have a peak to peak voltage of 5 volts, right, and when I say that below and above cutoff frequency, then my frequency is less than FL, my output frequency, my amplitude will suppress, it will be less compared to what I give as a input signal. Input signal, my output signal is suppressed. In case of F greater than, my frequency is greater than the FH, frequency is greater than fH, again I will see the similar effect, again I will see the similar effect. That means, when we apply input signal which is 5 volts, my output will look suppressed, my output will be suppressed, alright. So, another point is, here we have R1 equals to 10 kilo ohm, R2 equals to 1 kilo ohm, right. So, if I calculate my gain is 0.1, gain is 0.1. If I want to increase the gain, right, the filter replace R2 with 100 kilo ohm. Then if I want to increase the gain, if I from 0.1 to 1 or to 10, I can keep on changing the value of R2. I can keep on changing the value of R2, because I have a gain which is R2 by R1, right. Right now R2 is 1, R1 is 10 kilo ohm, my gain is 0.1. If I make R2 equals to 10 kilo ohm, 10 kilo ohm by 10 kilo ohm, my gain is 1. If I make R2 100 kilo ohm, 100 kilo ohm by 10 kilo ohm, my gain becomes 10, right. So, 0.1, 1, 10, that means that I can change my gain with the help of R2. In case of passive filters, we cannot change the gain, we cannot change the gain. So, if this is the case, let us actually implement this circuit on the breadboard, and let us see what happens to our output voltage when we apply 5 volts peak to peak sine wave, right, when we apply 5 volts peak to peak sine wave. So, let us see on the breadboard. Sitaram is back, and he will show you the filter, on the breadboard. Yes, little bit more, yes, that is excellent. So, now what you see is, you have a high pass filter, you have a low pass filter, you have the operational amplifier, So, now you are using this operational amplifier in a inverting mode, that is why the gain of this can be changed by using R1 and R2. This, by changing this, you can change the gain, alright. For now we have kept gain of 0.1, we have kept the gain of 0.1, and we are applying the input to the high pass filter, applying to the input to the high pass filter, and then we will look the output at the low pass filter. So, again this is band pass filter. So, input at the band pass and output at the band pass. So, the only change between passive and active is that here we have op amp and we can change the gain, alright. So, let us see, let us apply the signal. We have, because op amp is there, we are using the DC power supply. Through DC power supply, we have already applied plus minus 15 volts as bias voltage. Now, if you see the screen, what you observe? You observe that a frequency of 50 hertz is given and the amplitude is given as 5 volts. The frequency is 50 hertz, amplitude is 5 volts. In this particular case, my output voltage, which is the voltage on the oscilloscope. What is output voltage? Let us see, if you can zoom in, excellent. Now, what we see is my frequency is 50 hertz. What was my frequency or the low frequency FL? My low frequency FL was 159.15 hertz. So, this is 50 hertz. So, it will not allow, and that is why you can see peak to peak voltage. Look at this, 200 millivolts, not allowing, it is very clear to see, right. It is suppressed, that is what we have discussed. The signal which is input signal and the output is completely suppressed below FL, right, below FL. It will also get suppressed above FH, we will see that, alright. Now, let us increase in terms of 20 hertz as we have written in the experiment. So, now we increase it from 50 to 70 hertz, we see that still it is suppressed because it is below FL, the frequency, cutoff frequency of the high pass filter. Now, we increase to 90, yes. So, you can see here also the function generator, he is increasing 90 hertz, right, but every time we do not have to really focus on function generator, because the same signal whatever we are changing we can also see on the oscilloscope. That is why we are not showing you every time when he changes the 90 hertz, 110 hertz, you can easily see on the oscilloscope, alright. So, you see here with the blue and yellow one is 90 hertz and 110 hertz. Now, he will change it to 110, okay. You can see now still it is not allowing to pass. Let us go further, let us make 130, 130, still same, let us make 150, still same, let us increase it to 160. Now, you can see again, right, the gain is quite 0.1. Oh, I see. See, I forgot, and he helped me to understand why I was confused. Why the gain? Why your voltage is not increasing, right? Why your voltage is not increasing? But the point is, here we have set the gain of 0.1. We have gain of 0.1 means whatever voltage is there, if you multiply by 0.1, the output will even decrease, right, output will even decrease. So, you see, if I am teaching you, still I forget, then you are learning, you would also forget, right. So, it is absolutely okay if you forget, but the point is, try to understand why you are not getting it. Immediately I was confused that I am applying 5 volts, why I am not getting output voltage as 5 volts, because my gain is 0.1. But if I increase the gain, we will see in another application, if I increase the gain, you will see the change, alright. Now, I am increasing the frequency, I will go till 1.5 kilohertz. Can you go till 1.5 kilohertz? Okay. If I go to 1.5 kilohertz, now if I go above 1.5 kilohertz, you will see suddenly again the gain will be less. If I keep on increasing 1.5 kilohertz, above 1.5 kilohertz, you will see the gain will decrease and the output voltage will even decrease. Suddenly you see 220, 210, 200, now again it is suppressing the signal, it is again suppressing the signal. But what if I can change the gain to 1? So, what if I change the gain to 1? So, now he is trying to put another value which is a higher value, that means you come on the screen, I will show it to you. So, now what I am talking is, now here we had R1 R2 equals to 1 kilo ohm, R1 equals to 10 kilo ohm, that means R2 by R1, right, was 1 by 10, which is 0.1. That is why whatever signal it was passing, right, the band it was passing was getting multiplied with this particular voltage by this particular factor. That means 5 volts by 0.1 will give us 0.5 volts, correct. So, you could see at the output, generally it was close to 400 millivolts or 300 something millivolts, right, when we were within this, we were above the FL, we are above FL, and or we are between FL, we are between FL and FH, you would have seen the voltage which was around 350 400 millivolts, right. But when now let us see, if I reduce this and if I change the factor to 1, that means I have R2 of 10 kilo ohm, I have R1 of 10 kilo ohm. In both the cases, if I change my R2 in this particular case, if I change my R2 to 10 kilo ohms, my gain would be 1. So, in this particular case, let us see how the circuit will work. Right. We will do the same experiment, that means that we will apply 5 volts and we will start from 50 hertz, and increase the frequency at a step of 20 hertz, right. So, let us go back to the breadboard, and what we see here is, now the resistor, this resistor, right, he has kept it to make the total value close to 10 kilo ohm, 500 ohms. So, he has to again get another resistor, because we want value which is 1, but if you do not have, that is fine. So, what is the value of resistor that you have? 10k, and the another resistor
10k.
So, then we have 1,
but cutoff frequency will be same.
Yeah. So, do we have another one?
5 minutes I will get it.
That is fine. So, the point is connect it back. So, the point that I was making is, if I if I change my resistance value, I could see the change in the output signal, right. Right now we do not have this resistor, and I do not want to invest this time of yours in understanding that if I change the resistor what will happen. But the point is, if you change the resistance here and if you convert and you keep the value same, right, you have to understand that the output will depend based on the gain of the amplifier, alright. So, now what we have seen? We have seen an active band pass filter and we have seen a passive band pass filter as an experiment. In the next module we will see band reject filter. So, the point is, until now what we have understood? We have understood the theory of the filters, then we have seen low pass, then we have seen high pass, then we have seen band pass, then we have seen active band pass, we have seen passive band pass, we have seen active low pass, we have seen active passive low pass, we have seen active high pass, we have seen passive high pass. This thing we have covered. The next would be based on the frequency, right. You remember low pass, high pass, band pass, all three checked. What is remaining? Band reject. That means a particular frequency you have to reject from the rest of the band. That frequency I do not like, that frequency I will reject it. So, to create that frequency, to create that particular or reject that particular frequency, we need a filter. The filter that will reject that particular frequency is called band reject filter. The band of frequency which is rejected, which is undesired, unwanted, that will be rejected from the band of frequency, that is why it is a band reject filter. Again, for band reject filter we will see how we can design this band reject filter using operational amplifier. The one thing that you got in this particular module is that if I use a passive circuit, then there will be a effect of loading. If I use active circuit, the loading will not come into play, correct. Now, try to perform it by yourself. If you cannot get the answer, if you are confused, if you are stuck somewhere, feel free to ask. Do not ask without trying at home or trying in the laboratory, right. Try first, you have some genuine question, ask, and we will try to get you back as soon as we can in your forum. I will help you to get the answer of whatever your question is, and also there are TAs who will help you out to understand how the things work. So, feel free to ask me questions if you are stuck in your experiments. Alright. So, in the next module we will see what is band reject filter. Till then, you take care. I will see you in next module. Bye.